So guys, today I'm here also instead of the former, but today it will be different because we will only talk about the project and how you manage the project together, how you can put the different parameters. I will show you today everything and how you extract results from ETABS. I will not go in depth in the seismic load, but I will show you where is a place you can put the parameter to define the S wave on the building. Okay, but I think next time the programmer will explain this in detail. So this is the same project you will do. So it's very easy because it's schematic, regular, not complex. Don't worry about this. So for this project, we want to extract anything. Like when we talk about the whole building, we are caring about displacement, total displacement of the building, and also we can and full building we are caring about. When we have a building like this, we want to check this building will absolutely deform like this. We want to check this displacement doesn't exceed the maximum limit. And also we have another thing called this, by the way, this called displacement. Okay, but there is another important factor or parameter we want to make sure it's safe, which is story drift. What is story drift? Story drift means you have like here displacement like this, but for this story, this is the displacement, and for the above story, this is the displacement. The story drift means you get this one minus this one and divided by this height. So we don't calculate anything of this. ETABS is a very good tool. It can calculate this for us. So this is the second thing we should check. And also the programmer, I think, talked with you about the shear lag. Did he talk about this? So today also I will show you how we can extract the shape of shear lag. And yeah, let's go and we will know everything by time. Let's go. So this is my model or my base model for my project and my team also. So I think the programmer started last time with ETAB to define the material sections, and he didn't talk about anything related to seismic, right? Yeah. So I want to ask another question. Did you know anything about seismic? Yeah, but it's very easy. We want only to calculate the force on the building, right? What is the force? Force of the seismic only, we can say F equal M multiplied by A. Okay, so we want to define on software A and or M and A, mass and acceleration. So for mass, it can get from the weight of the building and the live load or other loads we have. And A is a parameter of the seismic we have. So first we want to define this M and this A. Let's define it. By the way, this model is already run. So I will not change anything, but I will show you the parameter I already entered, because you know how to enter the parameter, how to assign, define the section. You know this, how to define the material, how to assign
All of this stuff you know. So first of all, you should go to define material properties. I already have. So let's see, take a look. I have here FCU 100 megapascal. It's nothing. It's very easy to define all of this stuff. We are caring about E and mass per unit volume. And also, define section properties. We have here beam, we have slab, we have shear wall, and we have also coupling beam. Okay. So here for frame, we will define the beam and also the column. Yeah, I forgot this. And for your project, the column will be reduced with the height. For example, for the first 20 floors, you will have column, for example, 100 centimeter by 100 centimeter. And after this, it will be reduced to 75 by 75. And that's it. Because the live load or the loads will reduce when you go up. So you should define many geometry of column. And also, I have slab section, slab 30. It will be given for you the thickness of a slab. And also the wall section. Okay, so we have here wall 100. 100 means is the thickness of the wall. Modify. Here is the definition of the wall, and here is the thickness, 1 meter. And here the outrigger. Do you know the outrigger? Yeah. So the outrigger is the same of wall, but it's like a big wall work as a column for this floor. We can put the outrigger at any floor, but with the experience and trial and error, we can say the outrigger is the best place for outrigger top floor and the third top floors. Okay, so for example, if I have here 100 floor, so for the 100 floor and maybe at 70 floor also. Okay, but Dr. Ammar also will give you when where you will put this outrigger. Yeah, this for the section. Another thing you should know about the sections, you should reduce the rigidity for each section. Okay, because in the time of seismic, this section will be cracked. So some of the rigidity of concrete will be reduced. So code of ESCE give us some value for this reduction values of the column or beam or slab for each member. So for example, for the beam, for example, I can say beam 40 by 100. If I go to the modify, you can show, you can see here property modifiers. Go to modify, you will see here for every parameter here, I multiply the inertia, for example, by 0.35. I made all this reduction for each parameter, but I don't make this for the cross area and for the mass and weight. But for others, yeah, I put this reduction. Okay? So for the slab, for example, or for column, no. For column, it should be 0.7. Yeah. Respecting for bending? I don't understand this question. Again?
That's what, like I quote and
Yeah.
How do we know how much we know we should actually?
We should reduce, you mean, right?
Oh.
Here we reduce. Yeah, according to the code. The standard give us this number to reduce. Okay. So here, for example, the column 0.7. Modify. Yeah, 0.7. Okay, but we don't change the area and the mass and weight. And the same thing for the slab. It will be, I think, 0.25. We can see here section slab. Yeah, 0.25. And also for the shear wall. It should be 0.3 or 0.7. So this for define of material and define of section, it's very easy to define. Here I only show you modify because I don't need to expand more time in this definition. You already know. I just remind you of this step. So after this, I run my model already, or no, I want to assign the lateral load. So here I say I have F equal M multiplied by A. Let's start with M. M here in ETABS means mass source. I want to get this mass source. So how can I define this? In definition also, go to mass source here. And in this, you can define new one or use the default one, but you go to modify. And here, you will have this one. I think in the default of the software, it will be checked on this one, element self mass. So no, I wanted to give the software my mass, my chosen mass. So I will remove this mark from here and mark this one additional mass and specific load pattern. Let me show you this one. Yeah. This is a new model. Just I want to go and show you how can I define. But no model here. Yeah. We can go first to load pattern here to define live load. Yeah. Okay, it's defined already. So here, mass source. This one I can here say modify. Yeah, this one. I will remove this one because I want to add myself and here specific load pattern to activate this part. So here I want to add dead load with factor 1 and also I want to add live load. And for live load, the standard give us also the number for this live load. It will be 0.25. And if you have another dead load like floor cover, because here the dead load means the on weight of the building. But if you have the floor cover, and you should have floor cover, so here you will add and multiplier, it will be 1 because it's a dead load. Okay, so this is the mass source. It's very easy to define. Let's return to our model. Yeah. We have here dead load and the floor cover, or dead and the floor cover and live load. Is it very easy? It is very easy. So now we have M. We want to define A. A here, we have a lot of options. If you know some about seismic, you know we have a lot of method to define or to solve the seismic. For example, the equivalent method or response spectrum method, all of this stuff. Here we will define the seismic as a static load, not dynamic. So here in define load pattern, I have already earthquake in X direction and Y direction. You should define one in X and one in Y. So here in EQX, let me get from the beginning. Here define load pattern. here I want to define, for example, earthquake X, and type of it is seismic. Here, when you choose the seismic, you will see here auto lateral load option activate. From here, you will choose the code you want to use for definition of your load. So here we will use ESCE 722 and say add new load. And for this one, you will go to modify lateral load. Yeah, and here you will define the parameter. From this parameter, you will get what? You will get this A, the acceleration affected on the building. Guys, you must know the seismic is only acceleration happening to the land or the earth, and we wanted to know what how much this acceleration happened to the earth affect on the building. So we would we transfer the acceleration of earth to acceleration of the building. Okay. So here we will define, for example, in X direction, we will unactivate all of this stuff. And by the way, here when you activate X direction plus eccentricity, this one activate. What is this one? This 0.05 small eccentricity should happen to the building. You know, here we have a lot story. So seismic load affect on the what we can say the center of mass of each story, and the building itself resist this force by rigidity of the center of rigidity. For example, if we have one plane like this, or one plane, and we have, for example, here column, and shear wall, for example, like this. Yeah. And here in the middle, we have, for example, what we can say core. It's a shear wall, but complicated, or combined of many shear wall. So for this, we can make it like this to make it symmetry. Yeah. For the center of mass, which the earthquake apply on this center of mass. Center of mass is the center of mass of this floor. Where is the mass of this floor? It's only the slab itself, and also the weight distributed on it, and also the half of shear or column from the bottom story and upper story. So for this one, we can say it's in the middle, because we have the same weight in anywhere. And for the rigidity, our center of rigidity depends on the distribution of shear wall and column, the member which can resist the earthquake. For this also, it will be in the middle. So center of mass and center of rigidity, it will be the same. So first, if they are not in the same, for example, this center of mass and this center of rigidity, the force of earthquake apply here horizontal in center of mass. This is a plane. Okay, and for the center of rigidity, this is the resist. So it will be here. When you have two forces not affected in the same point, you should have what? Torsion. So if we have center of mass and center of rigidity, both of them in the same point, so we don't have rotation. So, but our standard give us a small eccentricity, which is 0.005 or 0.05 of the length perpendicular on the direction of the force. Why of this? Because we can say, yeah, center of mass is in the middle, but we don't confirm this thing, because maybe some people, for example, as a live load, stay here, and here there is no people or no furniture or no everything. So we can say 100% center of mass in the middle, for example. depend only on the slab and weight of the column because live load may be changed from here to here. So the standard give us this, and there is another reason for this. So we should apply this small eccentricity to get a small rotation applied on the building. But here, I think for the simplification, we will reduce or we will remove this eccentricity. But you should know this if you want to design in building outside. So here we will remove any eccentricity and we will use only X direction. And here we will use method 2. Here is this parameter. I think, Mr. Omar, next time we will give you this parameter, how to enter and the value of this number itself. So I will go out from this. And go to my model here. Modify. Yeah, I have this stuff. It's very easy to know. Anyone studies seismic should know most of them. So now I have earthquake in X and earthquake in Y. So from here, I can say we have M and we have A. A, we can get it from this definition. The software itself will know A from this definition. Okay? Yeah. So now I finished everything. My model should be ready for running.